Hi, 8th grade. Today we are checking out lesson 7.2, representing a function. So remember that a function is a relationship between two quantities. And the most important thing to remember is that we can only have, for each input, exactly one output. So we are looking at inputs, which are x values, and outputs, which are our y values. And for each x, there can be only one matching y value. So to help us review that, let's look at the warm-up problem. We are going to choose from these ordered pairs, and we are going to describe what the function could mean. So I have 2, 4, 6, 8 different ordered pairs, but I only have 4 spots in my table. So let's pick a point. Let's start with this first one. If I want to include the point 1, 4 in this table, then that means I have already used an input of 1. So I cannot use any other ordered pairs that have an input of 1. So I'm going to cross off the point 1, 3 because I already have an input of 1 with an output of 4. So I cannot use 1, 3. Let's look at an ordered pair that has an x value of 2. I could either include 2, 6 or 2, 8 in my table, and either one is fine, but not both because, so I'm going to choose 2, 6. You may have chosen 2, 8. But regardless, I can only have one matching output for an input of 2. So I either need the point 2, 6 or 2, 8. So looking at my 2 points with an x-coordinate of 3, I can either put 3, 9 or 3, 12, but I cannot put both because each input can only have one output. Now I could include the point 4, 12 because 4 only has one matching output, which is 12, and 3 only has one matching output, which is 12. So it's okay for my y values to repeat, but not my x values. So let's check out. Today we are going to be learning how to represent functions in 4 ways. So these are considered different views. So it's just different ways to see the relationship demonstrated. So let's start by looking at the first way, which we're most familiar with because we talked about it yesterday, which is ordered pairs. We talked about a list of ordered pairs is a relation, and we list our x values first and then our y values. And our x values are like our input and our y values are like our output. But what's special about a function is that each input can only have one matching output. So this set of ordered pairs would represent a function because 1 only has one output, which is 28. 2 as an input has an output of 56. An input of 3 gives us an output of 84. So this would represent a function. So we can then represent a function also using a table. So I can take these same ordered pairs and I could represent them in a table. That's a different view of the function. So this table is representing this problem. Suppose a car gets 28 miles per gallon. In this situation, distance is a function of the number of gallons of gasoline. In other words, the distance I'm able to drive depends on how many gallons of gas I have. So the input, my x values, is the number of gallons of gas, and the output is the distance, and I'm going to measure that in miles. So you can see that my ordered pairs are directly plugged into my table. It's just a different way of listing them. And I have extended the pattern and added a 4th row using my unit rate. So a third way to represent a function is the graph. So the graph shows miles per gallon. So my x-axis shows the gallons and my y-axis shows the miles. So you can see from my table that each of these points are represented in my graph. My first point starting from the origin is right 1 up 28. My next point from the table is right 2 up 56. My third point from the table is right 3 up 84. And my fourth point in the table is right 4 up 112. And I have connected all of these points in a line starting at the origin. Now notice my graph does not extend past the origin in the negative direction because I can't drive a negative distance. I can't have negative gallons of gas, nor can I drive negative miles. So my graph starts at 0 and extends all the way through these points, continuing on in that direction. Now the fourth way to represent a function then is with the rule, and the rule just means an equation. So we are going to be using y equals mx plus b form as we're doing this. And you'll notice that the number that I multiply x by, my coefficient of x, is always going to be the same as my unit rate. So when I look on my graph, my first point is 128, and that's because that's my unit rate. I can drive 28 miles per 1 gallon of gas. So that's my unit rate, and so that becomes my coefficient of x. And that's always my rule. That equation is my rule for the function, y equals 28x. So now let's work one of these together, and then you will do the next one on your own. During 1 hour of walking, you burn about 257 calories. The total number of calories burned is a function of the number of hours you walked. How can you represent this function in 4 different ways? So let's do some ordered pairs and let's think about what we know. I know that in 1 hour of walking, I can burn 257 calories. So my first point is 1, 257. So if that is my unit rate, I can burn 257 calories per hour, then in 2 hours, I could burn twice that many. So I need to double 257, which is 514. In 3 hours then, I could burn 3 times 257. So 257 times 3 is 771. In 4 hours, I could burn 4 times 257. So I'm always taking my unit rate and multiplying by my number of hours. So now the second way to represent my function would be in a table. So if I want to make a table, I'm going to take the same information and I'm just going to list it in a different form. So I'm going to make my XY table, and I'm going to put my first ordered pair in my table, and then my second ordered pair, and my third ordered pair, and my fourth ordered pair. Now I'm going to add one more column to my table just to help us when we get to writing the rule. So the third column in my table is going to be y over x. And I'm going to look at that ratio to help me here in just a bit. But let's go ahead and look at our third way of representing a fraction, which is a graph. So we've already established that our x values is our time in hours. This is how many hours I walk. And my y values are the number of calories burned. So this is my very best handwriting. Let's try to write sideways. And I'm looking at my table here. I can see that my x values start at 1 and only go up to 4. So probably what I'm going to do is for my scale, I'm going to label my graph And I'm going to, let me scoot this down to give us a little more room here. But I'm going to count by ones on every other line so that I have a little more room in my graph. So here's 1, here's 2 hours, here's 3 hours, here's 4 hours. Now on my y-axis, I'm going to start at 0, but I need to go all the way up to over 1,000. So what I might do to make this easy, because I know I'm graphing a function, is I might just count by 257, because that way each point will have a specific location. So I'm going to skip lines again, but I'm going to make this first one, oops, I'm going to slide this over. I'm going to make this first line right here. So I'm going to make this worth 257. Then I'm going to skip one. And if I'm counting by 257, I can just label the scale on my graph with the numbers from my table. That way I can really easily plot these points. So now if I'm going to graph these points, I'm going to start at the origin and I'm going to go right 1 and up 257. Then I'm going to go right 2 and up 514. Then I'm going to go right 3 and up 771. And then I'm going to go right 4 and up 1,208. And I know that I can't walk a negative amount of time and I can't burn a negative number of calories. So I'm going to start my graph at the origin and I'm going to extend this line through. Finally, I should add a title. Oops. So I might call this Calories Burned While Walking, so that we know what we're looking at when we look at my graph. And now finally I need to write a rule for it. So remember, to write a rule, I'm going to find my constant of variation, or in other words, the slope of this line. So that's where I'm going to come back and use this column in my graph. I'm going to write all of my y values over each x value so that it looks like this. Okay, for the first one, my y value is 257. I'm going to put that over its x value, which is 1. So that reduces to 257. In my next row, I have 514 over 2. If I reduce that to lowest terms, and I could just divide that on my calculator if I need to, then that reduces to 257. In my third row, if I do my y value over my x value, that also reduces to 257. And in my fourth row, I'm going to put y over x, so 1,028 over 4, and that also reduces to 257. So my constant is, my y to x ratio is 257. So that's how I write my rule. This is my constant. So that is the number that I multiply by x, and that's the rule for my equation. So now it is your turn to take a look at this example with the freight train traveling 35 miles per hour, and I want you on your note sheets to represent this situation in 4 ways.